Have you ever looked at a coordinate plane and felt like it was just a mess of random lines? What if I told you that every single line, whether it's perfectly flat, straight, up and down, or tilted at a specific angle, has a unique DNA called an equation? Today at STEMBridge, we're going to decode that DNA. By the end of the video, you won't just be solving for X and Y, you'll be seeing the logic behind the grid. Stick around because we're going to tackle everything from simple horizontal lines to the trickiest perpendicular bisectors. Exercise 8.2, Mastering the Forms of Linear Equations. A step-by-step guide to finding the equation of a line. Our journey through lines. First, we will start with the basics, which is horizontal and vertical lines, covering question 1 and 2. Then we'll move on to the workhorse formulas, which is point, slope, and more, covering all parts of question 3. And then the advanced forms, symmetric and normal, covering questions 4 and 5. Horizontal lines. The rule of constant height. A horizontal line has a slope or gradient of 0. Every single point on the line shares the exact same y coordinate. That means y is equal to k, and k is the constant y coordinate of every point on the line. Application. We are going to find the equation of horizontal lines in question number 1. Here we have an ordered pair which is 2, 3. We need to find the equation for the horizontal line passing through this coordinate. The y coordinate is 3. That means y is equal to k, and here y will be equal to 3. For the second part, we have 8, 0. So the y coordinate is 0. That means our equation is y being equal to 0. This is the x-axis. Then moving to the third part, here we need to find the equation of the horizontal line passing through -5, 9. So the y coordinate here is -9. That means our equation is y being equal to -9. And for the fourth part, we have -3/2, -5/2. We will find the equation of the horizontal line passing through this coordinate. So the y coordinate is -5/2. That means our equation is y being equal to -5/2. Now vertical lines. The rule of constant position. A vertical line has an undefined slope. Every single point on this line shares the exact same x coordinate, and the general equation is just x being equal to h, where h is the constant x coordinate of every point on the line. Now, finding the equation of vertical lines in question number 2, here we again have the same coordinates, and now we need to find the equation for the vertical line passing through 1, 5. That means x will be equal to h, and here the x coordinate is 1, so our equation is just simply x being equal to 1. For the second part, we will find the equation of the vertical line passing through 9, 6. Here the x coordinate is 9, so our equation is x being equal to 9. And then we have -4, -7. Here x coordinate is -4, so equation is x is equal to -4. And for the last part, we have 1/4, 3/4. In order to find the vertical line, we will look at the x coordinate, which is 1/4. That means our equation is x being equal to 1/4. Now, the three core forms of a line. We have slope intercept, which is simply y is equal to mx plus c. Then we have point slope, which is y minus y1 is equal to m into x minus x1. And then we have the 2-point form, which is used when two distinct coordinates are given, assuming x1, y1 and x2, y2. Okay, the slope intercept form. When the slope, which is the gradient, and the y-intercept is given, then we use the y is equal to mx plus c form. For the second form, we use it when a single coordinate x1, y1 and the slope m is given. And for the third line, it is used when two distinct points x1, y1 and x2, y2 are given. Point slope and slope intercept for question number 3, first and second part. Here in the problem, we are given the value of m as 2 and c as -3. we will choose the slope intercept form, which is simply y is equal to mx plus c. Here we will substitute the values. That means instead of m, we can write 2, and instead of c, we can write negative 3. That means our equation is y is equal to 2x minus 3. For the second part of question number 3, we are given negative 5 comma 7, which is a point with slope 4. So we're going to use point slope, which is y minus y1 is equal to m into x minus x1. Substituting the values, we first get y minus 7, that is equal to 4x minus into negative 5. Then what will we do? We will multiply 4 with every term. That means 4 into x is 4x, and negative 5 into negative 5, that is positive 5. So 5 into 4 is 20. That means our final equation here is y minus 7 being equal to 4x plus 20. So if we move negative 7 to the right side, 20 gets added with that. That means our final equation is simply y being equal to 4x plus 27, or 4x minus y plus 27 is equal to 0. For the application of special slopes, which is 0 and undefined, we are going to tackle the third and fourth problems in question number 3. If we are given the coordinate, which is 4 and negative 5, but we have the slope given as 0. You should always know that a slope of 0 always means that it is a horizontal line. So the rule for the horizontal line was y being equal to k, where k is the y coordinate. For problem number 4, we have a point which is negative 2 comma 9 with slope undefined. An undefined slope always means that we have a vertical line, and the rule for a vertical line is x being equal to h, where h is the x coordinate. That means x is equal to negative 2 in the fourth part, and in problem number 3, y is equal to negative 5. Now we are going to move on to the 2-point form in question number 3, part 5th and 6th. Here in part number 5th, we are given the 2 points negative 6 comma 1 and 2 comma negative 4. We need to find the value of m, which is the slope. So firstly, we will use the formula of gradient, which is y2 minus y1 divided by x2 minus x1. Substituting the values, we get our slope as negative 5 comma 8. Now we are going to use point slope form with the first point, which is negative 6 comma 1, and then we are going to simplify that. So here we have 8 into y minus 1, and that is equal to negative 5 into x plus 6. Okay, so 8 gets divided by y minus 1, that results in 8y minus 8, and minus 5 gets multiplied with the term x plus 6. That gives us minus 5x minus 30. So our final equation for problem 5th is 5x plus 8y plus 22 being equal to 0. For the sixth part, here we are given the 2 points, which is 2 comma negative 4 and 8 comma 4. Firstly, we will find the slope. So we found the slope by using the gradient formula, which is y2 minus y1 divided by x2 minus x1. So we get our slope as 4 by 3. Now we can just use the point slope form with any of the 2 points. I'll choose 2 comma negative 4, and then we can simplify into forming an equation. So here we have 4x minus 3y minus 20 is equal to 0. Now we are going to be working with intercepts. We are having in question number 3, problem number 7, the x-intercept, which is negative 6, and the y-intercept as 5. We are going to translate them into points. That means if our x-intercept is negative 6, then our y will be 0. So that is our first point, which is negative 6 comma 0. And then in the second part, here we have y-intercept as 5. That means our x coordinate will be 0 and our y will be 5. The first point is negative 6 comma 0, and the second is 0 comma 5. And we know that the value of c is just 5. Finding the slope, we get 5 by 6, and then we are going to use the slope intercept form, which will be y is equal to 5 by 6x plus 5. So in our standard form, that will be 5x minus 6y plus 30 being equal to 0. Then for the eighth part, here we are given the slope as a negative 1 and our x-intercept is 11. An x-intercept of 11 means that our point will be 11 comma 0. And here we are given the value of gradient, which is negative 1 and point. So we can just simply use the point slope form. we will write y minus 0 is equal to negative 1 into x minus 11. Our final standard equation will be y being equal to negative x plus 11 or x plus y minus 11 is equal to 0. Now we will move on to the symmetric form. This is the symmetric form. X minus x1 divided by cos theta is equal to y minus y1 divided by sin theta. Here x1 and y1, they are a coordinate and it is a point on the line where theta is the angle of inclination. For the problem first in question number 4, we are given x1 y1 as negative 4 comma 2 and the tangent of theta as negative 3 by 4. So if we derive our trigonometric values, we know that tan theta is negative 3 by 4. So sin theta will be 3 by 5 and cos theta will be negative 4 by 5. Why? Because tan theta is simply the perpendicular over base. So we can assume that our perpendicular is 3 and our base is 4. Okay, now as we get the values of sine theta and cos theta, already our points are given to us. So we can substitute the values into our equation, which is x minus x1 divided by cos theta being equal to y minus y1 divided by sine theta. So this will be our equation, which is x plus 4 divided by negative 4 being equal to y minus 2 divided by 3. For problem number 2 in question number 4, we are given our coordinates as 6 comma negative 6 and our theta is 30 degree. So we can easily find the cos of 30 and the sine of 30, which is under root 3 by 2 and 1 by 2 respectively. Substituting the values in the symmetric form, our final equation will be x minus 6 divided by under root 3 is equal to y plus 6. Now we will move on to the normal form in question number 5. This is the important concept. X into cos theta plus y into sin theta is equal to p, where p is the perpendicular and as we know theta is the angle of inclination. In the first problem, we are given the perpendicular as 5 and theta as 120 degree. Finding the cos of 120, we get negative 1 by 2 and the sine of 120 is under root 3 by 2. Substituting these values into our equation, our final equation will be negative x plus under root 3 y is equal to 10. For the second problem, we are given our perpendicular as 10 while our tangent theta is 1. If our tangent theta is equal to 1, then we can use tan inverse of 1. That will give us the value of theta, which is 45 degree. Now finding cos of 45 and sine of 45, we get 1 divided by under root 2 and 1 divided by under root 2 for sine 45. Substituting these values into our equation, we will get x into 1 over under root 2 plus y into 1 over under root 2 and that is equal to our perpendicular which is 10. So x plus y is equal to 10 under root 2. Your linear equation toolkit, a summary of what we learned in this lecture. We know that the rule for horizontal line is y being equal to k, where k is a constant. The vertical line is x being equal to h. The slope intercept form is y is equal to mx plus c. The point slope form is y minus y1 is equal to m into x minus x1. The symmetric form is x minus x1 divided by cos theta being equal to y minus y1 divided by sin theta. And normal form is simply x cos theta plus y sin theta is equal to perpendicular. You've mastered the language of lines. Congratulations. Practice is the key to fluency. Try applying these forms to other problems to build your confidence. Have any questions? Leave them in the comments below. A strategic guide to exercise 8.2. Here we will be covering the rest of the questions from question 6 to question 11. Our journey from rules to reality. The part 1, the laws of interaction. We will be mastering the core principles of parallel and perpendicular lines and then we'll start applying these rules to construct geometric figures and we will translate a single line into its various algebraic forms. Part number 1, parallel and perpendicular lines. The rule of parallelism. Two lines are parallel if and only if their slopes are equal, which means m1 is equal to m2. Applying parallelism. In question number 6, first part, we need to find the equation of a line through -4, -4 and parallel to a line with slope being equal to -5. As we know, we will write the given data first. So our coordinates are given and we have our slope. So for parallel lines, m1 is equal to m2. So our required slope will just be -5. And we will use the point slope form as we discussed in the previous lecture, which is y minus y1 being equal to m bracket x minus x1. Substituting the values into our equation, we get 5x plus y plus 24 is equal to 0. For question number 7, now we need to find the equation of a line through this coordinate, which is 3, 7 and parallel to 4x minus 3y plus 1 is equal to 0. Firstly, we will use this equation, which is 4x minus 3y plus 1, and we will find out the slope from this equation. That means we will move the negative 3y to the right side and divide 3 from all sides of the equation. We get 4 divided by 3 as our slope. And we know that our slope is parallel. That means m1 is equal to m2. So we will simply just use the point slope form. Substituting the values into our equation, we get 4x plus 3y plus 9 is equal to 0. Now the rule of perpendicularity. Two lines are perpendicular if the product of their slopes is -1. This means the slope of one is the negative reciprocal of the other. Simply m1 is equal to -1 divided by m2, or simply m1 into m2 is equal to -1. Applying perpendicularity in question number 6 part 2 and question number 8. For question number 6 part 2, we need to find the equation of a line through 5, -1 and perpendicular to a line with slope 1 by 2. Firstly, we will use the logic for perpendicular lines. If m1 is 1 by 2, that means it will be divided on both sides. So that means 1 by 2 is our slope, m1 into m2, 1 by 2 divided on both sides of the equation, that gives us -2. That is our slope. And here we have our coordinate. Simply we are going to use the point slope form, and substituting our values, we have y plus 1 is equal to -2x plus 10. Our simple and final equation will be 2x plus y minus 9 is equal to 0. For question number 8, we need to find the equation of a line through our coordinate -2, -1, which is perpendicular to x minus 2y being equal to 0. Firstly, we'll find the slope of a given line, which is m1 into m2 is equal to -1. If we move x minus 2y is equal to 0, here minus 2y to the right side and divide 2 on both sides, we will get our slope, which is simply -2. Now we will use the coordinate that we got from there and the required slope and apply that into point slope form. So we get y plus 1 is equal to -2x minus 4, or simply our final equation is 2x plus y plus 5 being equal to 0. The power of representation, the many forms of a line. Translating equations. Here in question number 11, we have 6x plus 8y minus 11 is equal to 0. Firstly, we need to transform it into y is equal to mx plus c, which is slope intercept form. What can we do? We will isolate y first. That means we will move 6x and -1 to the right side, and 8 will be divided by all of them. That gives us y being equal to -3 by 4x plus 11 by 8. Here our slope is -3 by 4 and the value of y-intercept or c is 11 by 8. Now we need to transform this to intercept form. To intercept form is x by a plus y by b is equal to 1. We will move our constant to the right and make it equal to 1. How will we do that? Firstly, when you move our -11 to the right, our equation will be 6x plus 8y is equal to 11. 11 gets divided on both sides. That gives us x divided by 11 by 6 plus y divided by 11 by 8 is equal to 1. Here we have the x-intercept, which is a, and y-intercept, which is b. Basically the 6, which is the coefficient of x, and 8, which is the coefficient of y, it got moved to the denominator.